Number 31. They ask us to solve the equation. There's a variable, and so we need to isolate this n. Well, currently n is not isolated because you've got the -4 minus the 2 that's being multiplied by it, and you got a square root over it. But besides all of that, you've also got this -8 on the outside. So to get n by itself, what do you think we're going to do first? Well, before you ever bother the square root, you always get rid of anything outside of it. So let's first add this 8 to the other side. So now those cancel and the other side equals 4. Now that the only thing remaining on the right side is the square root and what's under it, now we'll get rid of it by squaring it. Okay, but if you square this side, you square this side. So now you have 16 equals, those two things cancel each other out, so -4 minus 2n. Now from here, this is just a two-step equation. We need to add the 4. So now we have 20 equals -2n, and the remaining step is to divide by -2, so n equals -10. Now, they ask you to check for extraneous solutions. So what you'll do is, you'll plug -10 in the n place. So right here beside the 2, you're going to plug in a -10. So take your calculator, okay, and you're going to type it in. So -8 plus the square root of -4 minus 2 times -10. If -10 is the right answer for n, when I hit enter, what should it say? -4, and it does. It equals -4, and that's what it equaled when I plugged in -10. So that means this is right. Had it not equaled -4, this would have been considered an extraneous solution, or it could have been the fact you just did something wrong. Now keep in mind that on the test, there'll be 4 choices. So if you're struggling with how to solve it algebraically, couldn't you just plug each of the 4 choices in for n, plug them in and see when you get -4, or whatever it is on the test? Okay, so number 32, what are we going to do first? Add 1, because remember, you always remove everything from the side of the square root first. So now we have the square root of 7x equals 7. Now that the square root is the only thing over there, what do? Get rid of the square root by squaring it and square this side. So now you have 7x equals, and now to isolate the x, and so x equals 7. Okay, for this one, you don't really need to type it in to check it. You can do this in your head. If you plug in a 7 for x, 7 times 7 becomes the square root of 49 is, and 7 minus 1 is, so it works. Okay, number 33. Identify the domain and range of each. When you hear the word domain, what do you think of? X-axis. When you hear the word range, what do you think about? The y-axis. What is the graph doing on the y-axis? So, we should probably get a visual of this. Before we do, can anybody tell me what this x minus 1 is going to make the graph do? Correct, right 1. Since it's up under the radical, it's a horizontal shift, and it's always the opposite. -1 is actually right 1. So let's graph it. Okay, see how the whole thing shifted right 1, and it's now starting out at 1, 0? So, 1 is an x value, 0 is a y value. So on the x-axis, doesn't it go from 1 and then forever right? On the y-axis, doesn't it go all the way to, even though it's right here, isn't that a value of 0 on the y? So it goes from 0 to infinity. Now, we never actually reach infinity, so you put parentheses beside those. But didn't we actually have a point at 1, 0? So you put a bracket, because you actually touched at 1, 0. The graph touched there. On the test, this is how they're going to write it. X is greater than or equal to 1. It means the same thing. If I tell you 1 to infinity, isn't that 1 and up, basically? Or in this case, 1 and right, because we're talking about the x-axis. Well, isn't x is greater than or equal to 1 the same thing? 1 and right? One. Think about it. Name a number that could fit in that x. Right, or 121 or 122. You could go forever, correct? So what would we write for range if we were using this kind of notation? 0 in this case. Okay, you take a second and try 34 by yourself, Will. Sketch the graph of each function. So the first thing we should do is put it in our calculator. But before you even do that, what's this plus 1 going to make the graph do? Left 1. This is a slope of 2. So let's look at it. So 2 square roots of x plus 1. Okay, see how the graph started out at -1, 0 because it got shifted left 1? Now to get some points to plot over here so that we can do our sketch, what do? Well, what's an easier, faster way? Second table. And then that gets you a lot of points. So instead of having to go one by one finding them, okay, so I need to go back down and get some points in the negatives first. Why when I got to -2, -3, and so on, it says error? Well, look at the graph. From -1 and over, there's nothing there. So that's why it says error when I look at the table. So my first point is at -1, 0, which makes sense because the graph got shifted left 1. My next point is at 0, 2. Now, to get from this point to the next point, didn't you have to rise 2 and run 1? Which is what that 2 costs. Okay, then to get to the next point, it's 3, 4. Now, you don't continue rising 2, running 1, rising 2, running 1, because that would be a linear equation. This is the square root. Okay, and what's another point? 4, 3? Is it 4, 3 or 3, 4? Okay, and then what's another point after that? Is it 8, 6? Okay. Now keep in mind, on the test, it's multiple choice. So you're just going to graph it in your calculator, look at the 4 graphs that are there, and pick the correct one. Okay, take a second and try 36. Alright, the first thing you would want to do is graph it. Okay, it's cube root. Oops, hold on. Okay, now, see how the shift says x minus 1 plus 3? Didn't that move it right 1 up 3? Right 1 up 3? Y'all see that? Okay, so now let's get some points. Second table. -7, +1. Then 0, 2, 1, 3. 2, 4. And then, where's the last one? A good one? 9, 5, or 9, 5 is it? Okay, so, oops, missed it a little. Now, let's talk about why over here you only see from here and then to the right, but with a cube root, it goes right and left. Look at this. If I try to take the square root of a negative number, like the square root of -16, it doesn't give me an answer because you can't take the square root of a negative number. But if I try to take the cube root of a negative number, I get an answer. That's why the square root only goes towards the positives, because you can never take the square root of a negative number. The cube root, you can take the cube root of a positive number or a negative number, and so that's why it goes towards the negatives as well. Okay, number 37. Describe the shifts in the following equations. Okay, what kind of shifts is this equation going to have? Right 4. Okay, This is a little confusing because they put it in the front instead of at the end where we're used to it. But this means down 1. Say that you're confused and you're not sure. Couldn't you just graph it and look to see what it does? Y equals -1 plus the square root of x minus 4. Oops. Hold on, let me try to fix that. Okay, so -1 plus the square root of x minus 4. Can't you see that it moved right 4 down 1? Okay, so now let's look at number 38. What kind of shifts is it going to have? That's going to move it right 3, and this is going to move it up 3. And if you're not sure, graph it and see what it moved on the graph. Okay, number 39, identify the x-intercepts. What is an x-intercept? The x-intercept? What's an x-intercept? Right, where it hits or crosses through the x-axis. So couldn't we just graph it and see? What is that x minus 1 under the radical going to do to the graph? Right, it's going to shift it right 1 unit. Okay, it shifts it right 1. So where's the x-intercept? 1, 0. So without even graphing this one, what's this going to do to the graph? Left 3, and then is it going to go up and down or up or down? No. So isn't the x-intercept going to be at -3, 0? But if you're not sure how to do it without graphing it, graph it and look at it. Okay?